Okay. I'll send you a link.
Would pro bike riders go faster if they took their helmet off?
Depends
Because the helmet is making drag,
that much.
really. And it's also weighing them down. And it's also distracting them.
I also says there are lines.
I don't know. Maybe once in a while it helps, but.
You got the link?
Science open discussion. Register and join. Should I register and join?
Do whatever it's doing.
It's asking me to register and join. First name, last name, and your address.
Do whatever.
Right. Don't expect Mike Siegel to be there, it's just.
Alright.
So you can deduct one person on your registration. The deduction of people on your registration. Both has one, you let them know you're here. On wave 18, can you let me in? Dad, can you let me in?
I know.
You can't?
No, Mark Harlan. Mark, you're 1 hour early, and I'm practicing some Zoom stuff with my son Micah. Can you hear me, Mark? Why is Mark not muted? Mark, can you hear me? Can you hear me, Mark? Yeah. Hello, Mark.
Oh, um, sorry, I was just getting my is my microphone on?
Yes, you're 1 hour early.
uh, yeah, I know. Um,
Well, I'm just practicing some features with my son. Then I'm going to turn this off and come back on. Probably. I might leave it, but anyway, I guess you're welcome to stay if you want.
right, right. No, of course I will clear off for you to prepare. But can you point me in the direction of the videos that I noticed
yes,
recommended to be watched?
climatecurious.com.
Okay, I can see it behind your head. I will go there directly. Thank
Yeah,
you
and
very
then
much.
it just scroll down, you'll see a bunch of videos, and then come back in 45 minutes.
Thank you ever so much. Cheers.
See you then. Okay.
Bye bye.
Okay, Micah. I'm going to practice some things. I cannot unmute you, but I can unmute you in another way.
Look, I unmuted myself.
I'm working on, let's see, I mute you. And now what? I thought I could unmute you. No, it says ask to unmute. And I thought I could unmute you. Here, what do you see now? And then what do you do? Okay. So that's what we can do there. Okay, raise your hand.
So what I have to do is I click react and then I can click raise hand.
You don't see hand raised?
No, I do see it here, but you have to, it's in react, just so you know.
Not for me.
But for me,
Let me see. You see Q&A?
no. Oh, yes, I do. All right, look. But this is normal. What people will do instead, this is for every single guest, is they click react and they have a bunch of reactions, and one of them is great. Right? But the way to do that is you click the heart button here, react. I want you to tell them that you have to do that. Yeah, I know. I see Q&A right here. No, it's not there. Because raising hand is a reaction, just like be right back. Look. And then off the back, if I click again. Right there. Turn off raise hand. You just click again. Click again. Now, Q&A, I've never done this before. But why can't I just do the chat for that?
It's different. The chat can fill up all kinds of stuff and questions stay questions. And in fact, I could answer the questions by typing if I wanted to. Okay, submit a question. Anything, it doesn't matter. I don't see any questions. It doesn't matter. I'm going to delete it. I understand.
You see it? Yeah. How long are your 50s and meters?
Okay. Fine. Okay. I can delete that. Okay. Done. Does this say climatecurious.com up here? Does it look good? All right. Do I look a little unpink? Yeah. I could look a little pinker. Don't let him do it. You can get. All right. Now I want to. Okay, raise your hand. Raise your hand. Raise your hand. Raise your hand. Okay, great. Now, is your hand unraised? No, is it still raised? Oh, it is still raised? Got it. Hold on. Micah, I'm learning. Ah, there, I can lower your hand. Okay. I want to see the chat. I want to see. I want to see the chat and I want to see the people. Okay, I got to ask GPT a question. I want to see the chat and the participants. I'm reading. Hold on. Help out. Hmm. I don't really need you to do anything. I just have to learn something here. Pin. What does pin mean? If I pin you, what does that mean?
If you pin me, that means
Yeah.
everyone can see me.
It means you'll be on the front page of all the people. Is Jan? Hey, Jan, can you hear me? Jan? Jan?
Dad, do you still need me?
No, I don't.
All right. I'm exiting the
Wait, hold on.
server.
Hold on.
Hello, I can hear you. It's Jan.
Jan, hi Jan. You're early and we're just doing a run through. Can you come back in half an hour?
Sure, just checking. Thank you.
Have you seen the videos on the website, climatecurious.com?
I've seen them, but I haven't done my homework.
So go watch some of the videos and come back in half an hour. We're just doing a run through here.
Lovely. Thank you very much.
See you soon. Okay.
Bye.
Bye.
Um,
I did yesterday. No, I don't want to keep. A lot of these people are at companies. I'm not going to bug them.
Company?
I'm not. They're going to think I'm spamming them. I just sent one yesterday. Said go watch the videos.
It feels like people don't know what to do.
Some people will come early to a Zoom meeting. That's for sure.
Like, it's not just that they're coming early. The same people that come on time are gonna be the same people that
I have
still
to focus here. I'm reading how to fix this.
How to fix what? Primate curious. Primate curious. McNugget? Oh. I don't want McNugget. McNugget, tiny babies. So they're gonna know it's funny. Never been in nations. McNugget.
Okay.
he keeps biting my arrow effects and it's really bad.
Be careful.
And I cage for all my meetings now.
Well, then he's going to make noise.
Yeah, that's the issue at hand.
Problem.
The issue at hand in which.
Oh, give him a tree of those seeds, you know?
Oh, what now?
You know, the little, millet seeds.
No, Jaeger Malay. That big nugget attacks my arrow text now. Big nugget, you will be in prison. You will be in prison. This is true. No, it is true. It is. You will be in prison for the illegal actions. This.
Put on a hat.
Put on a hat.
Yeah, like your tennis hat.
That won't help.
Cover up your parapet.
No, he still bites it. Because it has to be on my ears. On my ears.
Okay, you can really destroy those things.
Yeah, I know.
It won't be hard.
Yeah, I know. That's why I don't let him do it. You think you want to destroy my arrow? No, I own you. You want to? And I am free. This is what it is. You will be a mighty. Small pumpkin. Small pumpkin.
Okay. Thank you for coming. I want to just quickly go over the rules today. for today's session. No rudeness, be respectful in talking and in the chat. Don't attack the person or the organization. Focus on the facts. Be specific. We're talking science today, no politics, no policy. You will need a paper and pen. So if you don't have a paper and pen or pencil right now, quickly go get one while I go through the rest of this. Hurry, everybody. I would like everybody to have a piece of paper and a pencil. All right. Please use the chat. Introduce yourself in the chat. Connect with others. Give them your email and your website. Just don't be rude or negative, but feel free to use the chat. It's a good resource. We'll use the Q&A feature to ask questions. You should see it in the bar at the bottom. If you don't see a Q&A feature at the bottom, check in more, which is in the lower right hand of your panel at the bottom. Look in more for Q&A. That's where we're going to ask questions by typing and not with the mics, because it's much faster to do that. You can type in a question anytime and we'll get to them one by one. Okay. For speaking, if you want to speak, we're going to use the raise hand feature. Now, if you don't see raise hand at the bottom, click on the heart icon and you'll see raise your hand, and you can raise and lower your hand there. All right. Okay. Now, how many people have prepared a short presentation? Anybody? Does anybody have a 2 to 5 minute presentation prepared? All right. If you have a presentation prepared, you can raise hand now. All right. A bit about me, your host. I'm David Siegel. I wrote my first book on climate in 1991. It said, of course, that humans were destroying the climate with carbon dioxide back then. In 2015, I spent a year looking at the data, a whole year, and I changed my mind after questioning the assumptions of the IPCC and looking at their methods. Since then, I've spent about 6,000 more hours studying, writing about, and making videos about climate science. 6,000 hours I can never get back. I'm a member of the CO2 Coalition, a science advocacy group. My only source of income from climate research is what my students pay me, less the cost of running that platform we all use to communicate, which comes out to about $800 in total income over the last 35 years. The CO2 Coalition is not funded by oil companies. It is almost entirely funded by small individual donations. Now, here's the agenda for today. People who have prepared a short presentation will go first. Then I'm going to ask people to say why they believe CO2 is causing climate change. Then we will take questions. And we have several experts here in this group who will help. We have an IPCC expert. We have the author of this book, which I use as the textbook for my class. All right, if you want to speak and say something, use the raise hand feature later. For now, it's just for presentations. Now, not everybody who wants to speak at any given time is going to have a chance. We just have too many people, but I'll do my best to give people time to speak. Then in about an hour or so, I will give a 25-minute presentation that I hope you'll find very interesting and worth sticking around for. You'll receive an AI summary by email, and I want you to know I'm recording this meeting, and the video will go on my YouTube channel at Cutting Through the Noise on YouTube. If you're here, that means you consent to being in the video. If you don't want to be in the video, turn your camera off or leave. Everything I do is very open. I don't want to hide anything. Let me see your hands now, your physical hands. How many people have watched the video series on my website on radiative versus thermal framework? Anybody? I'm expecting not that many. All right, fine. Now for the first poll, just to get everybody calibrated, we'll start the first poll. And that is, how much CO2 is in the atmosphere? What percentage CO2 is in the atmosphere? Okay. And the second poll now is, say what you believe to be true. So now we'll do the second poll.
But if he starts, he's gone right in the lead.
Oh, it's good and quiet in there.
No.
Corin, how are you?
Yeah, I'm very well. How are you?
You're not the first one today.
Very good.
There were
I'm
some
del-
other people. There were some other people showed up early, and I sent them away.
well, I'm very delighted that other people are very keen to
Yeah,
understand the error of their ways.
yeah. Hey, Micah,
So,
you know that guy Ted Dintersmith who gave that talk, TED Talk? Ted Dintersmith, he's a venture capitalist. He said he'll talk to you. Yeah, yeah. All right.
good news. Good
Yeah,
news.
well, we have 70 people registered today.
70.
Let me see. Let me get the latest number here.
Yeah, that's a big change from 18 last time I heard.
I know.
Yeah.
72.
72.
You know how
So,
many people will actually show up?
evening classes are about 21.
Well, most of the people are in the United States,
Okay.
but it's during the day for them.
Yeah.
So
They may be
21,
working.
low
Yeah.
20s.
Yeah. Something like that. That's a good result, whatever.
Yeah, it's a lot of work.
Yeah.
I would be glad if more like 40 or 50 would be better, but we'll see how it goes.
Okay. Will somebody attend who understands Haber's equations on the behavior of CO2 and why it doesn't trap heat so much at increasing concentrations?
That's just in a database. It's been measured. So
Oh,
Happer has made equations on based on that, but we learned it through measurement. So it's
oh,
based
okay.
on it's based on real world data.
Okay. Well, that's amazing. So you can measure a molecule up in the sky or do a laboratory experiment.
No, I lied. I'm sorry. We can measure where we are with today's amount of concentration. That's all we can measure.
Mhm.
We can't change the concentration of CO2. And
Oh.
then the equations fit into that. And
Mhm.
and so you're right. No, Happer's the model is what's important.
Mhm.
And a bunch of people have worked on the model. I don't think Happer built the model.
Okay.
This is at ModTran. This is called the ModTran database.
Yeah.
And you can play with it yourself. You can say how many parts per million and which part of the earth and what altitude, clear skies, etc. And it'll give you the so-called absorption rate at that point.
Yeah. Okay. So,
And he has all the equations in his paper, and I don't. I have no idea. It's too complicated for me.
yeah. I'm just, look, how on earth do you measure the behavior of a molecule a few miles up in the sky and it's only tiny and how much heat it absorbs?
They measure it. I don't know how.
Okay, fine. Uh, yeah. Well, well, you can do atomic, you can do engineering at an
Because,
atomic level, so why not?
well, you can also build tanks and measure in a tank and control
Yeah.
everything.
Yeah.
And in this case, you're not measuring the real world, but you can get those, you can see what the molecules do.
Yeah. Okay, that's science. You have to abstract sometimes. which sounds like I know any science, but I know they do that a lot.
Well, you can also use tanks to get any data you want, because tanks, since you control the environment, if you screw it up or if you get something wrong, you're gonna get the wrong information. So
Yeah.
tanks are generally a poor way to model the real world atmosphere, but it's an okay way to model. And this is what Arrhenius did. And this is
Oh, it was ages ago. Yeah.
in fact, Arrhenius discovered that there was a power law, that it was a logarithmic decay function. He discovered that, I think.
Okay.
And so it's possible to learn a lot in a tank. What you can't learn is how the real world reacts.
Yeah.
But you can learn the theoretical amounts.
Yeah. Because like some things, so if you've got steel or iron, you can heat it up, heat it up, and heat it up, and you can get to thousands of degrees. But as far as I understand, with CO2, it will only vibrate so much and generate heat and stop stuff going out, and that's it.
It doesn't generate heat; it absorbs and re-radiates.
Okay.
And you've read my thing about saturation.
Yeah.
It
I hope so.
well, that's in my videos as well.
Okay, fine.
It saturates
Okay, error.
in that range, in the 15 micron range. There's enough CO2. There's been enough CO2 for billions of years to do all the greenhouse effect it can possibly do.
Okay.
That has not changed since the Earth formed.
And the 15 micron range.
In the 14 to 16 micron band.
Okay, and that's the excellent graph that excellent why have I forgotten her name, from Greece. She
Liz.
presented that, yeah, Liz. She remembered that, and that we saw what absorbs and re-rates at what frequency.
That's right. And how
Yeah.
how about the wings?
Yeah, the wings of
That's right.
the oxygen.
That's right.
Yeah. Yeah, that was very good.
All right. People are
Good evening,
starting.
Mr. Lads.
The very beginning of the onslaught begins.
Hi, David.
Hi.
Les, how are you?
Very well, thank you. Very well.
Today we have 72 people registered.
72. Wow, that's impressive.
It's been a lot of work.
I bet it has. I bet it has.
So I always tell my kids, promoting things is much harder than you think. Even
Yeah.
just getting kids together to go ice skating is harder than you expect.
Yeah. Out of interest, when I followed the link to join the Zoom, it made me register again. Is that what you intended?
No, but it's the whole Zoom machinery. So whatever it is. I can't change
Yeah.
it.
Yeah, okay. It wasn't obvious that you had to register
Micah
again.
said the same thing, but I'm not sure. Maybe I clicked some button wrong. I don't know. I'm not sure. I imagine
okay.
people can get through that.
Yeah, yeah.
Yeah.
How you doing, Corey?
Good evening. Yeah, because I looked at a New Scientist article called Climate Myths, and so as you can imagine, it's New Scientist, so it's very much on the on that side of it. But they were saying, okay, it's basic physics that CO2 will cause more and more warming, but it's
Sure.
not, because
That's
we know, as you say, it's a saturation point, and there's a and you
Diminishing
say,
returns.
sorry,
Diminishing returns.
yeah, diminishing returns. So it's a bit obscure that I don't quite know why New Scientist would say that.
Why does Scientific American say it?
No, a New Scientist here. It's a publication here called the New
No,
Scientist.
why does Scientific American say it? Why does Yale University say it? Why does Columbia University say it? They all say the same thing. Why does the IPC say it?
Yeah.
They have their own reasons.
Yep. I think that's the case.
And that's what we're here to discuss. Politely with people of different viewpoints.
Excellent.
Yeah. That's the idea.
Yep. Likely. Very good.
Hey, Nigel.
Good. I'll be very polite. Good evening, and how
There
are
we
you?
go.
Yeah.
Exactly.
Yeah.
We're all here for the same reason, to learn and talk and discuss science. Soren,
David,
good evening. Yes,
David,
Nigel,
I
yes.
tried that other link you sent yesterday. It doesn't work.
Hi, Pete.
So
Perfect.
I've gone back to the Zoom one.
Looking at this.
Nice
Sorry
to meet
about
you,
that.
David.
Meeting, but
I wish I were better at all those mechanical things. I don't know.
Okay.
I don't know. I don't know why it doesn't work, but I'm not surprised either. Michael, you're in twice. Why are
Yeah.
you here?
I'm just going to log out on one computer.
Ah,
Very good.
all right. We have a busy day today. Here's Jan.
Recording in progress.
We're all
Well,
recording. It's great. I will put my phone on silent mode. Lee Scott Hammond, I think, is from Facebook, maybe. Hello, Lisa. Hello, Jan. Hello, Jaime. Here's Tony. Liz is here from Greece. We have a bunch of regulars. We meet this time every week, every Wednesday. We just have a bunch of new guests today. All right. Hi, Liz. I've dressed up my background.
What have we got? Oh,
I hope it's
you're in the South Seas.
I hope it's legible. I think it's Tahiti
Okay.
or Fiji. Tahiti or Fiji.
All right.
Okay. Free beer and chicken we don't have. We could have virtual, but it would be pretty rubbery tasting anyway. So I'm always trying to save money on my free digital food. Okay, I thought we would go through while the few more people come. We have 72 people registered today. So while people are coming, I'm going to ask a science question for the Earth as a reward for showing up on time. Here's the question. On a yearly basis, the sun sends a lot of energy to the Earth, and that same amount of energy radiates back out to space in the form of infrared radiation, all of it. So practically 1-to-1 ratio of the incoming energy coming to the Earth and going back out to space. If not, the Earth would just get too hot and just cook. Wouldn't take very long. So my question is, if the energy coming in is equal to the energy going out, what does the sun give us? What do we get from the sun? Now, I'm not asking people, I've got a bunch of class people, so you guys aren't allowed. The new people, anybody have an idea what does the sun give us? It's not really energy, is it? Any ideas?
Can you?
Huh?
Gives us good vibrations.
Vibrations. We can probably do better than that. Lee?
This reminds me of a question that came up on, there's a mathematical video that I watch on occasions. I can't remember the gentleman's name. You'll have to excuse me.
Veritasium by Derek Mueller.
That's it. It was a discussion about entropy.
Entropy, right.
Yep.
Does the sun give us entropy?
Well, that's a bastardized version of it, but it was something along those lines.
It doesn't. It gives us negentropy. It gives us the opposite of entropy. The sun sends us shortwave radiation, which is organized and has low entropy. And we can put that that energy to work because it's shortwave. And we can use it to power plants to make leaves and sugars. And we can use it to warm things. And we can use it, for example, for all those plants die and turn into oil and coal and gas. And so that gets used to to support life. And then it turns into heat, which is entropic, so it goes out much less organized. So what it really sends us is organization. You could almost say information, but it's more along the lines of the wavelengths, the frequencies of the light coming in. So one high energy photon coming in will be absorbed, and then about 30 low energy, long wave radiation photons will go out into space. And the energy is conserved, but we use the incoming energy to do work. And that heats the planet and runs life. All right, welcome. This is a pretty good group. I don't know how many people, but I was expecting that there would be a big no-show factor, and it's actually looking pretty good. So thank you, everybody, for coming. I'm your host, David Siegel. I'm going to run through some housekeeping items here and give you a bit of what to expect, all right? Please mute yourselves, keep yourselves muted, Lee, at all times, and that way we'll have an orderly meeting. And here's what I want you to know. First of all, thank you for coming to a conversation on climate that may or may not agree with your worldview. It's hard to get people who have different viewpoints on climate to actually be in the same room and talk to each other. So already we've accomplished a lot. I want to give a few rules. Please don't be rude. Please be respectful in talking and in the chat. Don't attack people or organizations. Focus on the facts and be specific. We're talking about science today. We are not talking politics, and we are not talking policy, just science. Please use the chat. Introduce yourself in the chat, promote yourself in the chat, your email, your website, your organization. Use the chat in a nice way without being rude, but please connect with other people. It's a great resource. We will use the Q&A feature to ask questions here. It's a Q&A feature that you may not see right now. And if you don't see it, click on More in the lower right, and you may see the Q&A icon, and that's how we're going to ask questions, by typing them. All right? And then if you want to speak, I want you to raise your hand. Your virtual hand is used to speak. Raise hand. Now, if you don't see raise hand at the bottom of your screen, it will be under React. Click the heart, and then you'll see raise hand. If you want to speak, raise your digital hand, okay? Sometimes they may ask you to just quickly show your hand just for a quick poll. All right, now, how many, and I'm just gonna do that right now, how many people, by show of physical hands, have prepared something to show to the group? Some 2 to 5 minute presentation. Alex has. Anybody else? Okay, raise your hand if you have a presentation. All right, and it's under 5 minutes, Alex? Is it short? You can just nod.
Oops.
Yes, it's short.
Sorry.
Perfect.
No.
Yes?
I was just saying, I don't know how I raised my hand. I just wanted to type something. Sorry for today. I have nothing to present, but I'm listening very carefully. Thank you so much.
Perfect. Okay, stay muted because we can't all unmute. And if you don't have a presentation, that's fine. That's okay. We've got several interesting things to do today. A bit about me. I'm David Siegel. I wrote my first book on climate in 1991. In 2015, I spent a year looking at the data, and I changed my mind because my first book was all about how CO2 was destroying the climate. But in 2015, I spent a full year looking at data, and I changed my mind after questioning the assumptions of the venerable IPCC. Since then, I've spent about 6,000 more hours studying, writing about, and making videos about climate science. 6,000 hours I can never get back. I am a member of the CO2 Coalition, a science advocacy group, and my only source of income from climate research is what my students pay me, less the cost of running the platform we all use to communicate, and that comes out to about $800 in total income over the last 35 years. So I don't have much financial incentive here. The CO2 Coalition is not funded by oil companies. It is almost entirely funded by small individual donations. You'll see here in the group, maybe a third of the people are members of my class. So here's the agenda for today. People who've prepared a short presentation will go first. Then I'll ask people to say why they believe CO2 is causing climate change or not. Then we'll do a few polls, and then I'll take questions. And then there are a few experts here. Is Andy here? Hey, Jim Steele is here. We've got a few serious experts here. I don't know if I don't see Andy and I don't see Javier, but we've got some experts here. And so we'll have a brain trust of people here who can help answer questions. And most of this content will be through question and answer. If you want to speak, use the hand raise feature. I can't get to everybody who wants to speak probably at any given time. There are too many of us, but I'll do my best because I want you to express yourself in this meeting. In about an hour or so, I will give a 25-minute presentation that I hope you will find is worth waiting around for. At the end, you'll get an AI summary of the meeting. Let me just make sure to start the AI summary and let me start recording. I better start recording right now. Oh, it's been recording. Oh, good. Okay, great. And I'll start the AI companion. So okay, great. And today is Wednesday, April 2nd, 2025. And I will tell you a little bit about my class just in case you want to join. All right, so just quickly by show of hands, how many people have seen my video series on radiative versus thermal view of climate science? Okay, people have seen most people in the class have, but a few people have seen it who are not in the class. That's great. All right, fantastic. Now, oh geez, now I've got to see okay. And finally, for the first poll, I'm going to start the first poll now just to calibrate everybody. The first poll is right here. How much, can everybody see the poll? Choose how much CO2 is in the atmosphere on a percentage basis. What percent of the atmosphere is CO2?
I don't see a poll.
The poll's not showing, David.
Now do you see it?
Yes.
Yeah.
Thank you. I got all the things working. I got recording going. I got the AI assistant. And now what percent of the atmosphere is CO2? And it looks like people are going pretty quickly. All right, so I'm going to stop that. And it looks like people are pretty knowledgeable. 0.04% is right. That's 4 parts out of 10,000. And they talk about it as 400 parts per million. Just to make the number bigger, 400 is a scarier number than 4. So it's 4 parts in 10,000. Very good. Here I can share the results, okay? You can see most people got it. Very good. All right.
Googled the answer.
Sorry?
They Googled the answer.
Yeah, they Google. They're fast. It's ChatGPT. All right. The next one I'm going to do here now. I think I'll wait till the first presentation. So that's the first poll. And now I will let anybody present. So if you've got your hand up, and that should be Alex, your hand isn't up. If you have a presentation, put your hand up. No, your virtual hand. That's all right. That's okay. So Alex, you know how to share screen. I'm going to let you share screen now. And
I swear I didn't touch my phone, but my hand is raised and I don't know how to lower it. I don't know how my hand can be raised.
I can lower
yes,
hands.
please.
That's okay. That's all right.
Okay, sorry for that. I don't know how this is possible.
I can do that. But I don't see too many other hands up, so that's fine. So we're going to go with Alex. We'll have a short presentation, please. You have to unmute, Alex. There we go. Unmute. Alex, you're still unmuted. Or you're still muted.
There.
Can we hear you, Alex?
Now can you hear me?
Okay, go ahead.
All right. Do you see my shared screen?
Yes, now we see. Yes. Go
Okay.
ahead.
This is a presentation that I started working on a long time ago. I'm Herman A. Pope. I go by Alex. I'm retired from NASA. I went to work at NASA in 1963 as a co-op at 19 years old, and I retired from NASA in 2007. In 2008, I attended a climate presentation by Tom Wasmuller, if any of you know him. And so I've been studying the climate since April of 2008. Let's see now.
Are you a member of the Right Climate Stuff?
I was supposed to be a founding member, but I didn't exactly join them because I didn't agree with them.
I see. Okay.
All right, I want to unshare that one. Let's see, I want to try to, hold on a minute. I need a bigger screen. Okay, so I've listened to and talked to and studied the works of a lot of climate scientists on the different sides. The consensus side of climate science has one hypothesis by definition. The skeptic side, we have many different hypotheses, and ours overlap with a lot of the consensus stuff. But I like to talk about the ice on Earth as a factor in climate change. They've told us that ice is formed and thaws inside the greenhouse so that it can be ignored in the study of energy coming in and out of the Earth. There's a major reason that that's not true. The ice on Earth is built mostly in polar regions and high places, but it's built when the oceans is warm and thawed and can evaporate and promote the snowfall. And sequestered ice builds up in the warm times and spreads out. And when it's the ice spreads out, it does cooling of the climate years later by thawing and reflecting. So a major warm time is when the major ice was put around the Arctic to start an ice age, and then that ice spread and continued gathering ice during the cold of the ice age. But once the polar oceans froze and once the oceans got low, there wasn't enough evaporation and snowfall to maintain the ice. And so ice ages ended because the ice thawed and depleted. And some people say, well, why didn't the oceans rise if the ice was thawing? Well, the ice around the Arctic was the heaviest, and it depressed the land, and that made it downhill, so most of the meltwater flowed into the Arctic. There are several studies that show that the Arctic filled up with fresh water and ice during the long cold periods, and the Greenland ice cores show the evidence of it. Let me see if I can find that.
Okay, try to keep it to 5 minutes, please.
Okay. So in warm times it snows and ice builds up and spreads out, and then ice thawing. And
we don't see your presentation.
Yeah, I'm having trouble keeping everything there. So let's go down.
Okay. Probably just best to make 1 or 2 points.
All right. The major ice ages ended because there's enough ice on Antarctica that oceans can't get deep enough and warm enough to cause another major warm period. And without another major warm period, we can't have another major cold period. But if you look at 10,000 years, 10,000 years ago, the sun heated the northern hemisphere more than the southern hemisphere. And over 10,000 years, the northern hemisphere gained less and less energy from the sun, and the southern hemisphere gains more energy from the sun. Yet in that 10,000 years, Greenland and Antarctic ice cores stayed in the same bounds. So that shows that the ice thawing and reflecting can overcome the difference in a huge amount of solar wind to the hemispheres. That says that the Earth is regulated by the water on the ocean and the water changing state. If you look at the ice on Greenland and Antarctica for 10,000 years, they're not in phase with each other, but they stay in the same bounds for all that time while the energy changed. And if you look at the last 40,000 years, the Greenland ice cores were very irregular. These irregular things is when the meltwater surges flowed into the Arctic, and the Antarctic ice cores, since the Antarctic was surrounded by ocean, it stayed in narrow bounds during the long cold period, while the Greenland ice was very erratic, and that's because meltwater was flowing in the Arctic.
We have an expert on that in our audience today.
Okay. And then when the warm time from 20,000 years ago to 10,000 years ago, it was erratic because the meltwater in the Arctic was breaking out of the Arctic in surges. But climate change is normal, it's natural, and it's regulated by water, its abundance and changing states. And I'll just wrap up for there.
Perfect.
I got lots more to say, but I don't have time.
Yeah, right. It's not meant to it's meant to lots of sharing and lots of people to express their views. So thank you very much, Alex. Can you stop sharing your screen now and we'll go back? Now, I'm not sure if anybody else has a presentation or has a response to my video series. Stop share, Alex.
I'm trying.
All right. Now somebody else has a Coric, you don't have a presentation. You don't have a presentation, do you? No. No, you're a class member anyway. We're trying to hear all the other voices. So I'm going to put your hand down. All right. Alex, I don't know if I can stop your sharing. Yeah, I can. There you go. No problem. All right. Anybody else have a presentation? I don't see any other hands. Okay. All right, great. Now I want to run another poll, okay, and see who's here. So here is your belief about CO2. Can you see that, everybody? I believe 1, 2, or 3. So vote now. All right, it looks like we're getting a bunch of people now. Okay. 30, 32. Is that about it? Everybody has voted? 31. Okay, we have 31 people. That's not too bad. Great. All right, so nobody said human CO2 will have a serious impact on the climate system, which is not too surprising because those people won't come to a conversation on climate science. It's too bad. I was hoping for at least a few, but we have 0. Or maybe we have some, but they didn't vote. I'm not sure. And then we have quite a few people. In fact, more than half have said CO2 has some effect, but it's manageable. And those people, I'm going to give them a chance now to say why you think CO2 will change temperatures and why you believe that. Why do you believe that CO2? Because it's very common. Plenty of scientists believe that CO2 will have some changes in CO2 from humans will have some warming effect. So please use your raise hand feature now, and it might be under the heart in React at the bottom, to say why you believe that CO2 from humans has some possibly minor but real impact on the climate. Anybody? I don't see any hands up. Wait a minute, Alex. Use your digital hand, please. It's going to be either raise hand or under the heart. All right, Mark. All I have to do is find Mark Harlan. Mark, unmute and let us know why.
Hello there.
What has convinced you?
I believe that you ought to have a fourth option in there. I think there ought to be an option for minuscule, but I do believe that there is perhaps a small amount, and that it is certainly not the problem that we should be bankrupting the world about. And I'm not a scientist, but I've listened to so many eminent people, particularly people like Mr. Happer and Soon and so on. And my feeling is that perhaps you might say over certain periods their CO2 might have some effect, but then as these things are cyclical, then probably that balances out anyway.
And the oceans absorb and emit CO2.
Yes, as I saw in your presentations, I looked at since we spoke earlier.
In response to temperature, CO2 comes out of or goes into the oceans. Let's let Pete Bonk unmute.
Thank you.
And by the way, the third option is really minuscule or negligible. Nothing to worry about. That's the third one.
Yeah, I debated about hitting the third answer there. So I'm right on the edge. I think I mean, we can certainly measure CO2, as some of the want to comment in the said it clearly is affecting the biosphere. It's certainly not in a bad way. So I chose that one, the middle, because it's manageable, and in a sense it's not really something to worry about, but it's real. And you know, CO2 is real, no question about that. But the effects are not necessarily bad, which is something we never hear about, that any good effects from the fanatics in the field.
But you did see my video where I showed that the first 50 parts per million is very much a strong greenhouse gas, and after that, hardly at all.
I did watch all the videos, and thank you. They're very good, by the way. David, I was very pleased to see those, and well done. Thank you.
So my point in those videos is that CO2 is a very strong greenhouse gas, always has been, and more from humans is going to be very negligible. Anybody else have a hand? Alex, go ahead. You can unmute.
Yeah, this is Sean. My question on your graph where you showed that the CO2 in terms of it, where the frequencies had very little effect. What I didn't understand was at the outskirts of that red line in the graph, whether the effect of CO2 actually had a greater effect, and not, I don't know to what extent, looking at your graph, that actually affected the climate.
Great question. I'm going to show that graph in my presentation. So unmute and interrupt me right there and we'll go through it.
Thank you.
Yes, good question. Who else? Alex, go ahead.
Okay. I believe CO2 has no measurable influence on the radiative energy balance, but it has a big influence on how green things grow and the efficient use of water. And in that way, it does have an influence on the climate.
Yeah, and that's what we just heard from Pete. That's right.
All right. Yeah,
Right
he
on.
said it first.
Yeah. Yeah, it's a little sad that the right climate stuff people didn't get their whole story together because it seems to have faded away. But I liked it when it came out. Anybody else want to say why, if you think there might be some? For example, people will say, well, yes, there will be an effect from more CO2, but it's manageable and we shouldn't be spending trillions of dollars to decarbonize. We can just adapt to the increase in temperature from added CO2. If you're in that camp, if you believe that, just unmute and say why. Anybody? Oh, I've gathered the whole choir here to be preaching to. Oh, come
Right.
on.
I didn't figure out how to raise my hand, but I've unmuted. Is that
Just
fine,
unmute,
David?
yeah.
Yeah, okay. If you're in that camp, I'll just speak as if I were there. But if you're in that camp, I don't think, I mean, to begin with, I have something with sort of firmness with which the scenarios are presented, because these scenarios, T+1 or T+2, they're really averages of averages of averages, right? Temperature is variable everywhere. Temperature and weather is variable everywhere. So, winters are colder than summers everywhere. Well, I mean, of course, you don't really have a winter on the equator, but day and night have different temperatures, you know. Saying T+1 as an average of averages, it's an average across space over the entire Earth. It's an average across time because you got 365 days, and every day, even inside a day, you have variations, and then it's yet another average because these are simulations which themselves are not exact. They're not deterministic. Weather is not deterministic to begin with. And so all of these simulations rightly do not give deterministic answers. And the solution is typically run a certain scenario, say 10,000 times, 20,000 times, and then average across that. And really, this is not T+1, it's an anomaly. It's an anomaly. It's what it would have been in another simulation without increased CO2 to what it predicts under that model, which is itself, of course, has lots of uncertainty. So it's an average of an average of an average to what temperature or weather would otherwise have been. Now, I mean, people live in Paris or people live in Nice, and Nice is a bit warmer than Paris, or people live in Barcelona, or people live in Valencia, and Valencia is a bit warmer than Barcelona because it's closer to the equator. So if that is the change that we have to abide with, I couldn't possibly see why that would be a problem, because people live in Nice today. So if Paris tomorrow has the climate of Nice today, then people in Nice live happily. People in Valencia live happily today. So if that's the climate that Barcelona is going to have tomorrow, there's not really much reason to move, etc. So this, but it's even more deceptive than that. This T+1 is not really a T+1. The average, which they call an anomaly of 1 degree, the average is maybe T plus 0.5 at the equator, and maybe T plus 6 at the North Pole, and maybe T plus 3 at the Antarctic, the South Pole. Mind you, T plus 6 at the North Pole is still deeply in the freezing territory. You've still got ice at the North Pole, right? You've still got ice at the Antarctic, and you may get more ice at the Antarctic. So people don't really understand what these predictions tell you and what you should be concluding from that. And if you think about it, what they really tell you at the scientific level, then I think mitigation or adaptation, or even not worrying at all, is potentially an acceptable strategy.
Yeah, doing nothing is my favorite policy. I want everybody to know that the global mean temperature is just a political construct. It's just used for marketing purposes. The only time you can really use it in a scientific way would be to talk about over geologic periods of millions of years, You could say that the Earth's temperature goes up and down, mostly in relationship to our distance from the sun and the obliquity angle and so forth. You could say, for example, that 570 million years ago, it's very possible that Earth was an ice ball, even at the equator, covered with ice. And in that case, you could say that you could talk about the gradient, the temperature gradient from the equator to the poles. And you could say at the equator that the average temperature was below 0 degrees Celsius. And this is the kind of thing we go over in detail in my class. And in fact, we have a lot of the researchers who do this work come and present their work to us every week. So it's a pretty interesting class. I want to just make a little advertisement. If you're interested in this stuff, Jim Steele, who's in our audience here today, will present next Wednesday on wildfires. He's a wildfire and grassland ecosystem expert, and he's going to tell us a lot of fascinating stuff about how wildlands burn. And every week we have different exciting people. We have solar researchers, ice core researchers, people who work on atmospheric radiation and on planetary motions, ocean people, all kinds of really interesting talks all the time. I'm sure that most of the students here would say that it's pretty much worth coming every Wednesday for a live talk. And if you don't make it, everything is recorded on the platform. So you have access to our platform where everything is already there. And we've got over 50 lectures and conversations there, plus a whole series that I put together on understanding climate in pretty serious detail. And I think most of that is still not wrong so far. So that's worth watching in general. And we have conversations, and we try to bring questions and learn from each other all the time. It's very, very good use of time. I know that most everybody here is not a climate alarmist, unfortunately. Mark, did you want to say something? Mark Harland, or yes, please do.
Yeah.
I'll let you go ahead.
Yes. But I think the problem that we all face is that there are so few people that can relate to things that they did maybe when they were 12, 13, 14, 15. They all looked at the carbon cycle in school, and yet suddenly with climate alarmism, they've all forgotten that. And there are a whole lot of other issues where we forget what we learned. And now, and also, I would like to say that I'm very much invested in the fact that there is global greening with CO2, and it is something that we all have to explain to people. We have to point this out all the time. As far as all the issue about CO2 is concerned, the two things that have struck me the most are metaphors, and the first one, well, actually not both metaphors, but the first and most brilliant one from Professor Happer about painting a barn. Well, I spent my working life selling coatings, and so that's a pretty good metaphor to attract my attention sharply, and to say that you can paint a barn once or twice red. It doesn't matter how much more you paint it; it ain't going to get no redder. And so that is something that I'm very much invested in. And the other thing is from Dr. Patrick Moore, when he says if you're concerned about rising sea levels and so on, then either move or talk to the Dutch. But it is something that is within the capability of us all to affect. So there you are. That's just what I thought I'd add to the conversation.
One thing a lot of people don't understand is temperatures are rising. We're in a warming period coming out of the Little Ice Age, and I'm going to go over that in one of my graphs. There's no question about that. You could decarbonize the world right now and stop all emissions, and you could reverse all the emissions of the humans, whatever, and it wouldn't change things at all. It's still going to get warmer. Seas are going to continue to rise at about 8 inches, 20 centimeters per century for the next couple of centuries. So be prepared for that 8 inches. Let's call it less than 1 inch per decade. Sorry. It's less than 1 inch per decade for the foreseeable future. So be prepared. As long as you can handle that, I think we're going to survive. Tilak, please. Welcome to Tilak, who is a wonderful writer and who is always out there on the front lines and who can maybe tell us a little bit about his experience.
Thank you. Thank you, David, and thank you so much for inviting me to join your group. I just wanted to talk slightly. Most of you, from what I gather, are scientists or art sciences. I'm an economist, so I track a little bit of the literature that you guys are very familiar with. But from an economics angle, we look on this question about carbon via the social cost of carbon concept. The cost in economic damages due to 1 extra ton of carbon dioxide. And as you know, or you might know, that there's a massive literature out there on the social cost of carbon. And there's
one Nobel Prize.
Yes, William Nordhaus won the Nobel Prize with his integrated assessment model that articulates a climate model with an economic model. And at the end, scientists can, hard science people can advise, but the guys who convert that advice into policy actionable items would be the economists. So the economists come in the equation in a vital way in translating the technical hardcore science to actionable policy outputs.
Otherwise known as wasting of tax dollars.
Yes, exactly. And as we saw, for example, in the COVID period, there was no economics involved. There was just sheer propaganda and alarm, and then panic buttons and shutdowns. There was no cost-benefit analysis. So I'll end with the simple point that there is a strong argument that social costs of carbon are in fact negative, not positive. In other words, more carbon means it's better for us. We should encourage China to have more coal power plants because in geological time, the amount of CO2 in the atmosphere is in fact at very low levels. We want 1,000 to 1,500 parts per million when primates flourish and everything else flourishes. So the social cost of carbon could very well be positive.
So can we do something, Tilak, can we do something for economists? Because I know a lot of economists and they're sure that they have to pay attention to this and that there's a big issue here. So how can we affect them? How can we help them understand the science better?
That's a tough one. That's a really tough one. Economists, I mean, those technical models that you guys handle is extremely complex, but economists are not unfamiliar with complex models themselves, right? We
that are usually wrong.
yeah, of course. We invented chaos in that joke between economists and physicists. But I think it's a question of pedagogy and debating styles. That's why Alex Epstein, who wrote the book on
Fossil Future.
Fossil Futures, and I reviewed that book for Forbes. That was so excellent because it was an exercise in debate and convincing people. It was the use of language to cut across barriers and stop us from talking past each other. So I think we should all inculcate those skills that Alex Epstein has written so well about.
It's unfortunate that he doesn't understand the climate.
No, he doesn't. He doesn't. No.
Neither does Bjorn Lomborg.
No, in fact, I was just struggling over an article that I need to write on John Lomborg. He's one of those warmest, lukewarmers. And he wants us to throw money to innovations as if innovations will come out. I mean, we've done nuclear fusion for 50 years and it's always 50 years in the future. So
Right.
He wants to throw taxpayers' money into in whatever green innovations are. I don't know what they are.
He can also predict world GDP to 2 decimal points in 80 years. That's impressive.
Anyway,
That's the great thing about
he's done.
economists.
I mean, to be fair, he's done very good work. I mean, he's opened so many. When I was young and I read his Climate Skeptic, that was an excellent entree into debate about the climate. So he's an ally, but we mean, as allies, we can have debates within each other. But he's not a climate alarmist like what the rest of the world is like.
He's going in the right direction. For
Thank
sure.
you.
For sure. Okay, anybody we haven't heard from, or if Jim Steele wants to say anything. Jim Steele's one of our resident climate experts. Let me hear from anybody who hasn't spoken yet what your beliefs are. You can put your hand up or, just unmute, and not people in my class. We're the audience.
I'm just listening today because I'm talking next week. So
okay, fine. So please join my class next week. You'll have to pay the big sum of $150, but Jim is well worth it, and we will have many more exciting.
Well, wait a second. How much of that 150 am I getting?
You get all of it.
You're kidding. I don't expect any of it.
Just send your money to Jim, and we're also going to have some thorium people coming to talk. We also talk about energy in the class. So we'll be learning a lot about thorium and nuclear this year as well. We've had some excellent presentations on the sad situation with renewable energy and how more renewables makes everything worse. And the data is phenomenal. The presentations have been really good. We're learning about grids and blackouts and things you don't want caused by people who are trying to save the world.
Can you hear me?
Yeah, sure. Go ahead, please.
All right. Thank you. I can say this much. I'm a physical geographer from Sweden, living in Denmark. And I react to these questions you pose that I often can't answer them because I'm just uncertain, often most. And my point would be that the IPCC and the media and policy are more certain than us. And I just wrote. Actually, I took a late bachelor in political science, intelligence analysis, just to sort this out. And I'll link in the chat the final essay I wrote, and it also has my take on the climate science. Here you go.
Thank you. Great. On my climatecurious.com website, we have a fantastic presentation from Soren Hansen in Denmark on how bad the energy situation is there and how it's getting worse. And it's really one of the best presentations we've ever had. So I highly recommend people see that. And just because you're a geophysicist?
No. Physical geography.
Physical geographer.
I did marine science.
Can you tell us
but no longer.
Can you tell us about land subsidence in Scandinavia?
Yes, very much.
How much of Scandinavia is sinking? Oh, it's rising. I'm sorry, it's rising.
It's rising.
Scandinavia is rising. Tell us about that.
It's rising about near Stockholm, 0.5 meter per century. So it's very obvious, and northern Sweden, it's 1 meter per century. Almost.
How widespread is it? Where else? What else is rising?
It's roughly Fennoscandia, Nordic, down to Denmark. Then there's normal, and also this there's a zone of sinking as well.
Sinking. Is Denmark rising?
It's roughly on the 0 line. Yeah.
Okay. All right. Why don't we have somebody from the class say how complex it is or how it helps answer somebody who is a more of a layperson, maybe Rachel? Do you want to tell people your experience in the class?
Yes, I'd love to. Yeah, I must admit, David's sales page, his original sales page, thankfully he's now changed it. Basically said, unless you're highly intelligent and have got a master's degree, don't bother. And I was like, oh no, I just wanted to learn more, and I very nearly didn't sign up. And in the end, I just convinced myself and said, well, even if I can't manage most of the class, I'll learn a bit more than I've learned than I know now. And as it turned out, I've been fine for about 90% of it. I learned more in the first 2 weeks of his class than I have in a whole year trying to study on my own. So if you do need to speak or at least articulate things about climate in a way that is from a point of knowledge, because my first council speech, I made the mistake of saying how little CO2 there was in the atmosphere because I didn't understand how it all works. So that showed I didn't know my topic properly. So I highly recommend it if you do have to speak to people in that kind of capacity, but also just people in general who just spout what they've heard on the BBC. And it's a very useful course from that point of view, and a very friendly group.
It is. We have fun every Wednesday.
We do.
Hey, David, could I ask one question?
Yeah.
I'll be talking about wildfires and climate based on mostly a lot of my experience in California and my research. But to make sure I cover everybody's concerns as I prepare, do anybody have any things they want to say they're especially interested regards climate and wildfire?
Wildfire questions, anybody? No, I mean, your presentations are so good and so thorough that it would be a shame for anybody here to miss that next week. So be sure to come next week.
I mean, there's a lot of interest from the reinsurance sector in wildfires, right?
Sorry?
There's an awful lot of interest from the reinsurance sector.
Yeah.
Oh,
in wildfire. Swiss Re had some losses in January.
Right.
Others far less. I haven't had any.
Actually, Jim, I would be very interested if you could talk about the work of Pat Brown.
Yeah, he just had a nice takedown on Daniel Swain's.
Because I think he's often right and sometimes wrong, and I'd like to know.
I think he's a good voice, and I just read what he put out because we were talking about something similar, the hydroclimate whiplash idea.
If you want to give us any breakdown, I especially want to know where he's wrong about wildfires and climate.
I'd have to look a little more carefully before I spoke.
I'd be interested because I think he's in the Berkeley group of, he's in the echo chamber that makes it. He's breaking out of that echo chamber, but he still has roots there.
As a lot of people do.
I want to welcome Andy May. Andy May is a special person who I've had the good fortune of having. He tolerates my questions, my relentless bad questions, and I really appreciate that. And Andy May is a specialist. Well, no, he's very deep on so many areas, but let me just ask Andy, if you will tell us a little bit about the IPCC, maybe a little bit about their background, because you've only written a couple of books on this, and their latest report and why their ideology is frozen. Do you mind?
No, I don't mind at all. Sorry I'm late. I got tied up. Okay. But the IPCC's biggest problem is their ideas are frozen. I mean, their initial assumption is that CO2 is controlling climate. That's the foundation of their models. And so the models show that CO2 controls climate. the problem is that the models don't match observations. And I think John Christie's plot is often, people don't understand how important it is. His plot is the middle trophosphere in the tropics.
I will be showing that.
Oh,
But
good,
anyway,
good.
yeah.
So that is where the greenhouse gas, the greenhouse effect should be the strongest. And the models indeed do show it to be very hot and a very strong greenhouse effect. But because in that particular region of the atmosphere, the um, there is no hot spot that the models predict, it really invalidates their models entirely. And I think that's not appreciated enough. So the models are getting worse. As you go from AR3 to AR4 to AR5 to AR6, we're getting farther and farther away from observations in each iteration of their hypothesis. And as a former computer modeler myself for 42 years, I can tell you that when each iteration of your model is getting farther away from observations, you've got a fundamental problem with your initial assumptions and your model design, and you've got to go back to the drawing board. I guess that's the summary I would give.
Dick Linzen keeps saying that the science group, the working group one, material is pretty good. Now, I've read a bit of it, and it looks like just a bunch of opinions to me, but you read all of it. What's your assessment of the science? What do you call it? The scientific basis.
The scientific basis is incorrect, as I just said. I don't. I mean, a lot of the data in the IPCC reports is very useful, very helpful, very solid. It's just that, like so many climate papers and reports, the conclusions don't match what they're showing in the data part. The data part's good. It's somehow they twist themselves in knots so they can always make CO2 the villain here, and there are so many other things that are affecting climate. Jim Steele has written some great posts on other factors that affect climate that they're ignoring.
Do you think that these researchers with PhDs writing these chapters either know anything or are trying to obfuscate, or they're just being, I don't know, compartmentalized and told what to write? What do you think?
Well, my opinions have evolved. I used to think that they were just, misled. They had opinions and they didn't want to back away from them or something like that, or it was some kind of personality thing. But now I think it's deliberate. I've went through all the hassle of publishing a peer-reviewed paper, and so I was able to see up close just how really corrupt the peer review system is. And I've shared some of that online. I've got more to share, but unfortunately, the main actor and who's really been beaten up on this whole process. I mean, it wasn't really me because I didn't care that much, but there's somebody else involved. He still doesn't want me to publish any of the stuff because actually he's thinking of suing. So it's no, it's really, really bad. And anytime you see paper retracted and it's a climate paper, it's probably factually correct. We were really lucky that our paper was not retracted. I mean, we were that close.
Wow.
Even though it's a very solid paper and everything in there is solid. So I'm not going to write another peer-reviewed paper I don't think any time in my life. It was just too grueling and distasteful. So yeah, there's a lot of coercion out there. Oddly, the journal itself was reasonable. It was wily, the publisher that was pressuring to have our paper retracted. And then the journal actually stood up and said, no, we're not going to retract it. We invited it.
Wow.
And, you know, it's a legitimate point of view.
Wow.
But Wiley had them publish 3 papers that were critical of ours. None of them landed a blow, but that was, and they admitted Wiley forced them to do that.
Amazing.
So Wiley, Elsevier, all those various publishing outfits, they have a really, really vicious bias when it comes to climate change.
Amazing. Well, my question, I have a question that you may have some insight. Why are there so many Chinese authors on so many papers now? It just seems like an army of Chinese PhDs churning out papers.
I don't know. There's a lot of Chinese. I
No,
mean,
I mean, in the IPCC process, it has really changed. The
yeah, well,
government is throwing money at these people for some reason.
Yeah, there are a lot of Chinese. They have a very good education system, and they've got a real focus on engineering and science, whereas in the U.S. we don't. So that's, I think, the main explanation of it.
But if you trace it down back to the party, to the Communist Chinese Party, what incentive would they have? And they have a lot of incentives to get involved with the IPCC process, to install so much solar and wind in their own country that they know, I'm sure they know, is ruinous for their grids. I mean, how much of this is signaling, and does it just serve political purposes, political ends?
Oh, maybe. They would certainly like the rest of the world not to have energy. So I think, yeah, they're putting in a lot of renewable windmill type stuff in China, but their fossil fuel use is going through the roof, especially coal.
Yeah.
The same in India. India is a little more honest. They come out and tell you you're stupid for using wind and solar. The Chinese don't say that.
Well, that's what I wonder, because they know very well that it screws up their grids and it's a disaster. So I think they're doing it for signaling reasons and maybe for marketing reasons, to help promote that the rest of the world goes on this drug that they're the ones who build them and sell them. So maybe it's a marketing tool.
Could be a marketing tool. Could just be they want to take over in manufacturing. They've made that clear. So,
yeah.
And their education system emphasizes science, mathematics, and technology. I mean, they're all out on that.
Yeah, I'm afraid that the government is sponsoring all their research on the IPCC, and they're doing to the IPCC what they've done to the WMO and other groups, and that is to have as much influence as possible. Tilak, it would be very interesting to try to understand this, because I can't imagine it has anything to do with science.
Yes, actually, within Asia, and I've been based in Singapore most of my life. I work around the world. I'm now in London, but with the Chinese, with the Indians, it's a bit clearer, but with the Chinese, it's extremely difficult to understand, because the CCP has got a larger game out there. And if you read some of the more perceptive papers that the GWPF, the Global Warming Policy Foundation, have published on China, in particular, I forget the lady's name, superbly aware of what's going on. The bottom line is that legitimacy in China is raising living standards. They do have, you can't just run a country roughshod with whips and lashes and security services. You do need to have people on your side. And to have people on your side, you need to raise the standards of living. And no planner in China who spends most of his time reading, political economy and real politic rather than this garbage climate alarmist stuff, they are aware that this is a great way to participate in the international community of nations and say, yes, we are all for renewable energy. And
Right.
look at us, we are producing wind and solar, but they've got wind and solar completely dominated. It's become one of the major export industries, while those very wind and solar facilities and components that they produce for export are produced by coal power.
Yeah.
Yeah, they consume more coal power than the rest of the world put together.
Yeah.
Now the Indian power minister has come out openly in some of the Conference of Party United Nations meetings saying, look, you want to bring yourselves down, that's fine, but we've got to bring ourselves up. We've got poor people. We don't have the luxury beliefs that you guys can afford. So we have to have coal. And coal, by the way, the fourth generation power plant coal.
Oh, it's fantastic.
They are super clean. I remember William Happer showing in an excellent video saying that fourth generation power plant, its exhalation, its emissions are as clean as a baby's breath.
Yeah.
Unless you're fixated on CO2. And as we know, CO2 helps plants and people prosper. The Roman warming period, the medieval warming period, the great cathedrals were built during that time. We want warm. So the China thing, I'm one of the greatest skeptics. I think China is playing a game. The senior guys there, you can't put anything past them. They know what the game is. Why not be a third world fighter and talk about the climate for public consumption purposes in United Nations forums? Meanwhile, we'll carry on doing what we do.
Yeah, India is doing the right thing. Andy, maybe we can convince Andy to come. Andy is an expert on global temperature and quality of life on Earth for humans and all the things that have happened according to all the different climate regimes. So maybe you can come and tell our because I've talked to it a little bit about it, but your work is fantastic. So it's something we'd love to have you.
Well, the strongest correlation that I've ever seen is between energy consumption and affluence.
Yeah.
And the second strongest is between energy consumption and environmental cleanliness. So
Exactly.
I think people are pretty off base. I'm sure you've all seen the plots. The more affluent countries use more energy, and it's energy use that's important. It's not necessarily energy price, as long as you can afford it. And so this idea of using renewables where they have to be backed up by fossil fuels that are on idle all the time, so you're paying for your power twice, is silly. I think some people in Germany and France, in particular, understand this, but they seem to have even a more corrupt system than we do in the United States. I mean, they actually throw their right wing in jail. So, I mean, of course, we tried to throw our right wing in jail, but it just didn't work. Let's hope it doesn't work in France either. But no, politics has completely corrupted science, which is why people don't recognize the connection between affluence and energy consumption. And as you said, the modern coal plants are very clean. There's nothing coming out of those smokestacks but steam. The biggest cause of pollution in Europe is are fireplaces and home heating stoves. You can't, and in fact, that's the case here in many cities. Denver is a perfect example. So you really need to be careful, I think, burning wood in a fireplace or wood pellets in a stove, and then worry about the coal power plant way down the line because it's pretty clean.
Right, right. We just Joe Biden just managed to decommission the best one in the United States a couple of years ago.
Oh gosh.
In Arkansas. So let me switch gears now. I promised a presentation. I know a few people have hands up, but I want to go through my 25-minute presentation and then anybody then who wants to stick around and discuss. But this is new stuff. And for this next 25 minutes, I need you to have a pen and paper. So hurry and get a pen and paper. It really won't work to have another screen very well. It'll be much better if you have pen and paper. And it's going to be a little challenging. I'm going to put you to work. All right. I'm doing this for Tom Nelson's podcast next week. So, but you're getting a preview of it. So you get your pen and paper. I'm going to start sharing my screen. And get ready. Whoops, that didn't work. Okay. We'll do this right. Here we are. Can everybody see comparative thinking and motivated reasoning? Yes. All right. So I'm going to be asking you to do some work here, and we're going to learn about an interesting. Let me get my timer started. Interesting research study conducted by Dan Cahan at George Washington University. It has a lot to do with how we understand the world around us. In this study, researchers made up a fictitious experiment where they gave a new kind of cream to people who all had the same kind of rash. Next, I'm going to show you the results of that fictitious study. I'm going to give you 30 seconds to decide whether the skin cream helped or didn't help. That's the question. Did the skin cream help or didn't help? 30 seconds. Here's the data. Which worked better, the cream or no cream? Write your answer on paper. Keep in mind, I can't see you and I can't see the chat, so I'm just going to keep going. So I can only see a couple of people. So now we'll take a look at the answer, all right? So here's the analysis. These numbers were just made up, okay? Most people just look at which numbers are larger, but you have to look at the ratios. Doing the math, you can see that no cream worked better. The cream, on average, made the rashes worse than no cream. This is the difference between System 1 and System 2 thinking. System 2 takes a bit more time and effort and is often the opposite of your initial reaction. And so the results showed that those who had higher numeracy skills got more right answers. This all makes sense so far, right? All right, so now I'm going to show two more sets of data. These are about gun control. Again, this is a fictitious study where they took cities without gun control and cities that enacted gun control laws, and they looked at the homicide rate over the following decade. We'll look at the United States first and then Australia. Take 30 seconds to determine which was more effective, with gun control or without gun control. With gun control or no gun control, all right? This is data for the United States. You have 30 seconds to come up with your answer. Did gun control work or gun control didn't work? All right, now we're going to go to Australia. In Australia, 30 seconds, did the gun control work or gun control didn't work? Some people may recognize this methodology from Veritasium video that came out about 6 months ago or so. All right, let's see what's going on here. It turned out that the researchers were not testing numeracy at all. They were looking at how politics affects our ability to understand data. So let's see what we can learn. Remember, these numbers are just made up. They have nothing to do with actual crime rates in the US or Australia. It's just a test. In the first one, you could have figured out that even though the numbers are larger, the ratios tell a different story. According to this data, cities with handgun laws saw crime increase 5 times over 10 years, whereas cities with gun control, I think I've got this wrong, saw an increase of only 3 times. Yeah, so no gun control saw an increase of only 3 times. So according to this data, gun control works and saves lives in the United States. Now, the next one, in Australia, cities that had no gun control saw crime decrease 4 times, whereas cities with gun control saw crime decrease by 2.3 times. So in this case, gun control is far worse than no gun control. Better to have gun control in Australia, according to this data, all right? So now, I want you to you've got your answers written down, okay? And I'm going to now explain where you might be according to your beliefs. But before we get there, I'm going to stop sharing and take a poll and ask you to say what you got. So here's my poll. I see. I can't do that right now. Okay, hold on. Let me go back and explain what the researchers showed. Sorry. Here we are. All right. So we have two answers here, US and Australia. And here's how the researchers effectively put it down. If you're rational and you're numbers driven, then you realized that that gun control made cities safer in the United States and no gun control made cities safer in Australia. Is that backwards? Crime decreased. Yeah, no gun control was better in Australia. Yeah, right. So in the US, according to that data, gun control made cities safer in the United States. No gun control was better in Australia. Now, if you're a liberal, you'll just say gun control always works. You'll have these two checked. If you're a conservative, you'll say, oh, gun control is bad. You'll rationalize your way to thinking that no gun control is always best. And if you don't really know how numbers work, you'll get both answers wrong. And that's what I want to test here by launching this poll. So let me see if I can get people to answer in the poll. And I think it's launched, right? So people are able to say that they're rational, liberal, or they voted, or they looked at it conservatively, or they just didn't understand.
Can you send it again, David? David,
do you see
can
the
you post
poll?
it again?
Can you see the poll?
No, I deleted it.
Oh, you completed it.
I deleted it when I went back to your other screen.
I don't have a way to do it again. Most people are getting it. I think 15 people have voted. It's because I put it up and then took it down. Most people, it looks like, are rational. Why don't we just do it by show of hands? How many people showing your physical hand had the liberal answers where you chose no gun control both times? Just use your physical hands. Not that many. Most people were, okay, great, Tilak. Okay, so that's the liberal answer. And then how many people got the conservative answer where you chose gun control is never good always should have no gun control. All right, and this exposes the political bias that confuses people when they talk about numbers. And this is why there's a very good video on this and why I wanted to present it. And now I'll keep going to show the next part of it. There's more to this story, all right? So what the researchers found was that the smarter people were, the more numerate and science literate they were, the worse they were at determining the effect of gun control. And they went through a bunch of other political number exercises for their paper. And when the data agrees with your worldview, you can process the math and find the signal. But when the data doesn't agree with your worldview, you misinterpret the data, you find a way to justify it, you say there's something wrong with it, and you've come up with the opposite conclusion because you're so smart. So they used motivated reasoning rather than rational logic. And the researchers did this for many different, for climate change, nuclear power, all kinds of politically charged topics, and they found the same thing every time. More scientific and statistically literate people were unable to detect the signal if they disagreed with it. And this is a key finding, and this is why there's no one in this event who is pro-warming, who believes that humans are causing significant warming through CO2, because they don't want to have anything to do with it. So in the case of all these things, the question is why? And that's what this paper, second paper, was about. Because the real risk isn't about, the first paper, sorry. The real risk isn't about humanity. The risk is about your own personal well-being. Members of the public with the highest degrees of science literacy were not the most concerned about climate change. Rather, they were among those whose cultural polarization was greatest. And so this is their conclusion in the paper. Given how much the ordinary individual depends on peers for support, material and emotional, and I would also add their salary, how little impact his beliefs have on the physical environment, he would likely be best off if he formed risk perceptions that minimized any danger of estrangement from his community. And that's what they discovered in this first paper. There's another paper coming. So I have created this framework, which I think may help people see what's going on. The first thing to understand is that different issues are personal for each person. The framework is what's important. If it's personal and visible, that's one category. If it's personal and invisible, that's another. So you can divide up all your beliefs into these four categories. If other people believe something that is very visible, and if other people believe something or think they are affected by something invisible, these four categories help bring it out. And I've changed the issues here because they're not the important part. Depends who you are and your peer group. I'm showing the framework to help break down where the sticking points are. So here is how I see it. If it's personal and you can see it every day, if it's in your face and you're living it, you're more likely to be motivated to speak out against the status quo. On the other hand, if it doesn't affect you personally, you may have a strong incentive to agree with the people you see every day. And this is why it can be so toxic to talk about certain subjects at work. Because people identify with their group and want to stay in their group, they often don't want to talk about the science of climate change. They believe what they hear from people like them. They hear from people they trust. I've asked hundreds of people why they believe CO2 is cooking the planet, and the answer is always the same. Well, because it's obvious. You're an idiot if you don't believe it. They have no interest in understanding the science. And that includes anyone in charge of climate policy or climate investing. They don't have time to learn because they're too busy saving the world. So here's an example of motivated reasoning. In February, I saw this. This came across my feed somewhere, and I reposted it on X. The picture is real, but it says that Krasnoyarsk has a temperature of minus 73 Celsius, which is like minus 100 degrees Fahrenheit. It's very visual, and within a few days, I had about 300 more followers than I had before on X. But I started to think about it. Everybody was reposting it so often, I became suspicious, and I learned that Krasnoyarsk does get down into the minus 60s, which is very cold. It's this cold, but the 73-degree claim was just made up by somebody. So I posted on X several times that I'd been wrong and I was looking for more accurate data, and I screwed up and I'm sorry, but my new followers were too busy reposting to their followers. And this isn't much of a lie, but it shows that people repost what they want to believe without fact checking. And then if they don't believe it, then they start fact checking. And this is an example. If you saw this kind of thing online, the rate of myocarditis from people who got the mRNA vaccines is 36 per 100 people. You know, would you boost that? Well, the risk of heart inflammation after getting the vaccine was indeed around 36 per 100,000. Many people interpreted this to suit their worldview, which is that vaccines cause dangerous side effects. But the risk of heart inflammation after getting COVID was 65 per 100,000. People only bother to fact check if they see something they disagree with, not something they agree with. We're all guilty of this. I do it probably every day. Among our in-group, messages we agree with spread very quickly, while messages we don't like face resistance. It depends more on you and your political views than your power of analysis. Obviously not going into the COVID rabbit hole. So to avoid being wrong, this is how my tool can help. To get away from politically biased thinking, here are my suggestions. If it's personal, don't assume that everyone has the same problem or everyone sees it the same way you do. For example, I have met people who believe all vaccines are bad for everyone all the time. That's just simply not the case. Penn Jillette says, Penn and Teller, Penn says, if it's something you want to believe, that's when you should question your assumptions most. By the same token, if you think nuclear power is bad or climate change is bad, ask yourself how you know that. These are invisible things. So you may have already formed some assumptions based on anecdotes, stories, and repetition, not from actually reading scientific papers or understanding the details. Double check your sources if it's invisible, and think critically about what you're being told. Two really good books on these topics are The Art of Insubordination, which explains how to build a following around your grievance and not do it alone. It also asks you to check your assumptions before you try to change the world. And this very obscure book that hardly anybody knows about is called Private Truths, Public Lies, about how people go along with the herd in public, even though they harbor doubts and question authority in private. Maybe the best book in this category I recommend for everybody is called How Minds Change by David McRaney. He still believes humans are causing climate change, but his argument is based on correlation, not causation. He doesn't really look into the details. He doesn't understand the physics, but his approach to changing minds is based on empathy and listening rather than lecturing in facts, because facts is not where the action is. So let's go back to Kahan. He did more research, not on scientific polarization, but on curiosity, and he found something interesting. This is his second paper. In the US, our two main groups here are liberal and conservative. While scientifically literate people of opposite political beliefs tend to diverge when studying the same data, scientifically curious people of opposite political beliefs tend to converge when studying the same data. The more curious and humble you are, the more neutral you are, the more you will converge toward the truth. And this is borne out by exercises you may have heard of called adversarial collaboration, which I think we should try to do more for climate science. That's actually why I invited as many people as I could from the people who believe that CO2 is doing terrible things, but they didn't show up. Not surprising. The reason I put the risk low here is that I've seen too much data and read too many papers, and I've never seen a single paper that shows humans are impacting the climate, or the temperature anyway. To me, it's except for the heat island effect, but not through CO2. To me, it's a case of not much correlation and zero causation. But hey, look, it could be the other way. I might be wrong. I've been wrong before. CO2 could have some measurable effect no one has measured yet. because maybe the signal is hidden. Maybe the data, maybe it's complex. Maybe we're going to have a breakthrough and learn more. So I need to be able to say what it would take to change my mind. Because I've changed my mind before, and I've learned things from people like Andy all the time. In 1991, I wrote this book on how CO2 was heating the planet. It was based on my reading of Al Gore's book mostly. And then in 2015, I looked at all the data and changed my mind, and I've been making videos and trying to explain what I've learned ever since. But I'm always learning new things about the climate system and revising my view. There's always a few little things that I've gotten wrong. So if I saw enough evidence that contradicts my current beliefs, I would change my mind back again, because I'm scientifically curious and I'm not married to any particular viewpoint. So what would it take to change your mind? What would it take to falsify the idea, whatever your idea is about CO2 and temperature or climate, or humans destroying the environment? What would it take? If you can say that, you're much more neutral than most people. So in this next section, I'm just going to present the main pieces of evidence in favor of the thermal model. This is just a quick overview. It won't take very long. And if you're not familiar with the thermal model, you didn't do the homework for this event, but you're on your way and you're learning. So here are my pieces of evidence. The first one, and it's been mentioned before, is that the solar cycles come in various cycles themselves, 11, 20 something years and 100 years and 1,500 year cycles. And these cycles can combine and amplify each other, and they certainly do. And this is what, and Andy May has written endlessly on this stuff. But this is the kind of thing that naturally drives our climate, and it's driven by solar variation on the scale of centuries. The IPCC, on the other hand, says solar variance is negligible, but it isn't. And this is the graph that someone asked about. This is Will Haffer's graph. I have a whole breakdown of this in lay people's terms, so I'm not going to spend too much time on it. But the area under these curves in pink here is the warming effect of CO2. The heat trapping isn't quite the right word, but absorption and re-radiation effect of CO2 in the first 50 parts per million is represented by this area. And this is the 15 micron band. And then this is 14 microns here. And this is 16 microns over here somewhere. And we've talked about this endlessly in our classes, but just to show what Will Happer was trying to show, if I take that out, it's a little clearer. The first 50 parts per million do a tremendous amount of warming, and they are responsible for life on Earth, without which we would be in big trouble. Then if you double that to 100 and double again to 200, and now here we are at about 400, that's the black line. So that's the difference between the base 50 parts per million area and just adding this much more around in the wings, we call it. This has to do with radiative factors that are sort of less and less possible, and they really tail off logarithmically just because they are statistically less likely to happen out here. And that just doesn't represent much warming at all. And if we had 800 parts per million, that would be this red line here. And you can see it's just not that much different if we doubled from here. So more CO2 from here is maybe we probably wouldn't be able to measure the effect from that, strictly from the CO2 greenhouse effect. And we haven't been able to measure this difference so far. And we probably won't be able to measure anything more from here. And it's the same, by the way, with methane, which I think Andy will tell me if it's here or here. But I go into that in my essay, which I will, send a link to after we are done. So that shows that it's negligible. Here, as we know, many people know that plant growth has increased across the globe by about 40% because we were dangerously low 150 years ago. And in fact, somewhere around 180 to 200 parts per million is where plants die. So in the 200 parts per million, it's just starvation, which is where we still are. And I want everybody to understand that first 50 parts per million that does most of the work, that has been around since Earth was formed, since Earth was just a cloud of dust and rock. The CO2 has been with us. Enough CO2 has been with us. It's always here. And it's just sometimes it's down in the ocean or it's locked up. If you're in Europe, it's probably under your feet. It's called limestone. It's all around the world. And it just at the moment, a lot of it is locked up. But the Earth has always had that much. That's sort of a lower than baseline amount of CO2. So they add more in greenhouses to get plants to grow more readily. A couple more pieces of evidence. According to the IPCC, as CO2 forces temperature higher, more energy will accumulate in the upper troposphere, and there would be a corresponding amount of energy not radiated to space because it's accumulating and warming the Earth. But here we see satellite measurements showing that both incoming and outgoing energy have increased, which is evidence that albedo has decreased. Albedo is reflectance, mostly from clouds. A small change in albedo can result in a huge change in temperature, and that's what we've been seeing for the last 20 years or so, plus a few El Niños and one volcano that was just happened to be in the right place. Couple more pieces. The IPCC admits in their technical chapter 9 that downwelling infrared radiation can't penetrate the ocean skin. It's impossible. They imagine that more CO2 heats the oceans anyway. Mostly the politicians do, but they have never shown that. Even basic physics textbooks explain that infrared radiation is too weak to penetrate water. The only thing that warms the oceans is direct sunlight. No amount of CO2 or water vapor can heat the oceans. The tropics receive a huge amount of energy directly from the sun. About 80% of all the energy entering the system at the tropics is radiated back to space one way or another. But 20% of that energy moves poleward and exits over the poles in winter. The transport of that heat drives our climate system. So that heat transport is where we should be paying attention and not on the radiative effects of CO2. Finally, and this is the graph that John Christie shows, water vapor is the main greenhouse gas, and the models don't know what to do about water vapor. So they are mostly based on CO2. And for more than 40 years, the models have been predicting warmer tropospheric temperatures in the tropics than we have observed. And this is supposed to be the hot spot that heats up the most. The red column is the average of all the models, and the yellow line is what we actually observe from measurements. Most models have consistently, as Andy pointed out, overpredicted this number by about a factor of 2. Since I can't find, and they know it too, but they don't change the models. And since I can't find anything in the IPCC reports that overturn these observations, I have to believe the CO2 hypothesis is false. And this leads to one of my most important lessons, which is that overall, across a wide variety of topics, skeptics have a better track record than promoters. If you think that all the past scares of eugenics, acid rain, the ozone hole, Y2K, methane, mass extinctions, pesticides, meteor impact, AI takeover, ocean plastics, and so many others, the press loves to promote the possibility of catastrophe, but you can bet consistently against those prophecies and come out far ahead. The two main threats I worry about are government overreach and the fast rise of stupidity as a result of the collapse in birth rates. Everything else, I think, is nothing really spectacular to worry much about. The precautionary principle says you must do everything to prevent something bad happening, even if it only has a tiny chance of happening. That would squander our resources on wild goose chases. If the assumptions are wrong, the solution won't work. Governments usually cause more disasters than they prevent. Free markets allocate resources.
Hello.
I'm almost done. Richard Feynman says, if your theory doesn't agree with the experiment, your theory is wrong. So the question you should ask yourself is, if you learned new data that didn't support your beliefs, would you change your mind? Or would that be too risky in the group of people you live and work with? If you can't say what it would take to change your mind, you're not scientifically curious. Finally, Feynman said, I'd rather have questions that can't be answered than answers that can't be questioned. I hope we can all ask ourselves new questions and be willing to have our assumptions challenged. That is how we move forward in understanding and solving hard problems together. All right, so that's my little sermon today. Anyone who hasn't spoken yet, please just unmute and say anything you like. Go ahead. If you haven't spoken, do you have anything to say, anybody? No? Next round. Anybody have any comments based on everything? I'll let Corin. Go ahead, Corin. You haven't spoken yet. Go ahead. Here, just unmute.
So I'm unmuted. Yeah, no, I just wanted to respond to what Mr. Steele had to say, asking what would be interesting for me in the class next week. So I read in the papers, they say that Los Angeles fires were 35% more likely to happen because of climate change.
Oh, yeah.
I also see someone else saying the actual figures are statistically irrelevant. Could Mr. Steele explain in words to people who are really scientifically and mathematically backward why the 35% figure is wrong?
Next week. You're muted, but that's for next week. That's for people who are in the class.
Yep.
I'm dangling Jim Steele as bait for signing up for the class because we're going to learn all about that. You wrote a piece on the LA wildfires, didn't you, Jim? You're muted. You're muted.
My wife just came in the house and is bothering me, so I had to mute myself. So I just started trouble here. But anyways, what was your question? I'm sorry.
About the LA wildfires and being caused by climate change. Don't answer the question, but I think you wrote a piece about it.
Absolutely, and that will be part of the talk.
That we'll be talking about next week, Corin.
And wildfire, it's from my
Thank you.
estimation, a lot of the people in your group are from Europe. So I'll look a little on European fires because it's California and the Mediterranean area have very similar issues.
Well, we know that Greece is burning because Europe is polluting because of smokestacks and tailpipes, I guess. So that would be something to look at.
But yeah, and I noticed on the chat that a few people had questions about what's natural versus human cause, and that will be addressed also.
Okay. All right, I'm going to wrap it up. Alex, do you have something quick to say? Sure.
David, may I say something?
Yes, Jan, please. You're in the UK somewhere?
No, I'm in Australia.
Oh, wow. It's the middle of the night for you. Wow.
My husband's a golfer and he loves to follow the weather, and he always gets correct weather predictions from AccuWeather,
yes,
but not from our Bureau of Meteorology. And I, in my conspiratorial brain, link this and wonder if there's anything to do with geoengineering, which I understand you're going to be talking about in future classes, perhaps, or if you even think that geoengineering is an accurate description of the lightening of the skies. But anyway, I was wondering if you have any awareness of why AccuWeather can predict things, but our Bureau cannot.
First, this is going to be a two-part answer. First is that AccuWeather has a wet bias. All weather predictions for consumers have a wet bias because they get yelled at if people go out without their umbrellas and they get rained on. They hate that. So there's a lot of strong feedback from the public to keep the forecast a bit wet, to keep people bringing their umbrellas out. And this is true. That's not for professional forecasters and people who have to forecast something like a rocket launch or something. But as far as what you talked about, cloud seeding and other geoengineering, Andy May is probably the guy who could say something about that, or about temperature predictions in Australia. Do you know anything about that, Andy? You have to unmute.
Yeah. Not really. In fact, I don't really follow the geoengineering stuff very closely because it's so hard to get definitive data. I don't know how much of that is really being done. You get all these conflicting reports. Some people say that jet airplanes are putting stuff in the air, and some people say no, they're not. And I really don't know. I'm sorry.
I see it on and off all the time, and when the skies are blue in Canberra, they used to be incredibly blue because of our low pollution rate and altitude, but now they're on and off blue, and you can see the planes. But I won't go into that. Just as a side note, someone told me very reliably that our authorities are using laser beams to burn out space junk before it enters the atmosphere.
Hmm.
And I think I've actually seen one in the evenings.
I'm not aware of, I know we have some very strong lasers, but that would be deep state activity. And this is just monster power to be able to do that.
Oh, well, this was broadly broadcast in our University of the Third Age by a reliable source. I don't know if it's deep state or just science.
It's just a tremendous amount of power. The lasers that can do that, there's probably two, maybe there might be one or two in the world.
Mm.
So I don't know. I'd be interested if you could forward anything on that to me.
I'll ask my friend.
Alex, did you have something quick?
Yes. On the sea level rise, sea level rise puts water around the equator and takes ice away from the spin axis. So sea level rise would slow down the spin rate of the Earth. Would make days longer. Since 1972, when they started the atomic clock measuring time accurately, the length of day has gotten shorter. So that's a strong indicator that sea level has actually gone down since 1972. Anyway, that's something to consider.
Andy knows all about length of day. Do you have anything?
Yes, sea level will affect the rate of rotation, but I think the wind speed and direction is probably the larger influence. You know, if you have strong zonal winds, the Earth speeds up. If you have strong meridional winds, it slows down. And I've not seen any calculations of sea level rise or fall. Sea level rise and fall is also determined by, in most basins, most ocean basins, by the wind. So you get kind of confused in there. The global average rate of sea level change is incredibly tiny. It's less than 2 millimeters per year. So, and it's not evenly distributed. You know, you've got sea level rising and falling in the Southern Ocean there around Australia, and sea levels going up in the Northern Hemisphere, especially in the Pacific and the Atlantic. So it's kind of confusing to sort it all out.
Well, again, time is measured accurately, and sea level is hard to measure and hard to average. So the errors in knowing sea level is a lot larger than the errors in knowing length of day. And the inertia, the crust of the Earth floats on the core. So all we're talking about is the change in ice and ocean compared to the crust, not the whole Earth.
Well, what about clouds? Clouds weigh a lot.
Well,
if you had more clouds, you'd change the rate of rotation. Is that true, Andy, or am I making that
but
up?
there's more water in the ocean. There's more mass of water and more mass of ice than there is mass in the atmosphere.
Of course.
So changes in the sea level is going to affect the inertia of the Earth more than the atmosphere.
Yeah, remember the LOD numbers that I've seen are also corrected for tidal effects. and the tides are the biggest movers of water, I think. The mass of water. So some of that's going to be corrected out. That's why LOD tends to mostly be assigned to wind speed and wind direction.
And we do have, I think there's evidence that during the major ice age, when the sea level was lower and there was a lot more ice on Earth, the Earth was spinning much faster then. So we know that part, the inertia of the ocean and the ice made that difference.
Yeah, and the
It
Earth
made
has
some
been
of it. Yeah,
slowing
the
down.
wind speeds were also much higher in during the last glacial period. So
yeah,
and the Earth has been slowing down rotation forever, so it's always slowing down.
That's a tiny bit.
Yeah. Yeah.
Anyway, that just consider that.
All right, we're gonna let anybody go who wants to. I will follow up with a couple of links to a few things we've spoken to everyone by email. I encourage you to come spend some time at my on my page and contact me if you want to join the class. I want to just ask one more thing of everybody. I recently published this, and I'm putting it in the chat. I want to help companies. I think companies aren't doing a good enough job defending themselves against net zero and ESGs. And so I've written sort of a new entry to my climate science site for people in companies and organizations. And I'd very much like to run, and governments who will, who want to wake up. I'd very much like to run seminars, workshops, and classes for people in companies and help them craft their message so they stop just catering to what the press and the analysts and Wall Street wants to hear about ESG compliance, because almost all of it is nonsense, and they don't have to put up with it if they can come together and do it as a group rather than getting nibbled away one by one. And this is a multi-trillion-dollar industry that makes no sense, and the money is in companies. So there's a lot of money in governments, but there's a lot of money in companies to try to fight against bad decision making. And companies should really be in the business of doing what they do as well as possible. They should be focusing on excellence and not focusing on box checking and initiatives that are driven by bad policies and bad ideas. So I really want to help companies do that, and please forward that URL on. It's kind of written in a gentle way to help people, to appeal to people who need help. And then secondly, anybody who has a group or wants to use this resource we have of all these brains to try to make any changes, just let me know, and let's be creative, and let's try to make some changes. We have a Slack group for people in the UK. So if you're in the UK and you want to join our anti-net zero group, I know some people here are in that group. It's just getting going. So just reach out to me if there's any way we can collaborate. And I hope to see a few of you contact me to jump into the class, because the classes are fun and we all look forward to our Wednesday sessions. Anybody want to close it out with any remarks? Anybody who hasn't spoken yet? Sean, did I answer your question about the, actually, I'm going to send you my essay on that, so you'll break it down.
I appreciate it. No, I still have questions about the red line exterior, but I'll listen.
I'll send you the essay, and then it's all laid out there in simple terms for normal people instead of for geeks.
Thank you.
I look forward to everybody next week.
Perfect. Great. All right, Tilak, everybody, Tilak, I hope to talk to you sometime. Let's get the economists to wake up and do the right thing for people instead of continuing to incinerate cash. Let's do that. If you have any initiatives, let me know. Let's get some things going. I really appreciate everybody coming. And I'd be happy to do more of this if we could just get those those climate crazy people to join us. I wish they would. I'd like to talk to them. I'd like to hear them. I'd like to listen and get them to help us explain how we can come to a better agreement altogether.
Thank you. And burning cash causes global warming.
So many things. And don't forget dandruff. That's my big one. CO2 and dandruff. Is there a correlation? Check it out. All right. All right. See you next Wednesday, everybody. Take care. Bye-bye.
Thank you.